Hello everybody! We are Guido and Chiara from the project HAMS, Hardware Acceleration of MATLAB Simulations. In this second video, we will explain why we have decided to use FPGAs in our work. MATLAB is an high-level language and interactive environment used for calculations. Thanks to its versatility and its user-friendly interface, it is nowadays very common in different fields. However, when computational-intensive calculations are executed on a general-purpose processor, the execution time becomes very high, often too much if compared to the user requirements. The aim of our project is to achieve a speed-up in MATLAB simulations by means of executing the most intensive part of the code on hardware devices. The first problem we have to face is to decide what kind of hardware device is more suitable for our aim. We will do a comparison between graphic processing units, application-specific integrated circuits, and field-programmable gate arrays. In order to make a proper choice, for each device we will analyze 4 features: the speedup with respect to the execution on a GPP, the power requirements of the devices, their flexibility, and, last but not least, their cost. Concerning the speedup, ASICs are surely the most performant devices. However, both GPUs and FPGAs can provide a good acceleration. Looking at the power consumption, ASICs are one more time the best option, since they are optimized for a specific task. Then we can find FPGAs, with a power consumption of tens of watts for our needs. Finally, GPUs, with some hundreds of watts. Concerning the flexibility, ASICs are inappropriate, since they can't be reconfigured. On the contrary, GPUs and FPGAs are both programmable. Finally, considering the cost, we can see that ASICs are convenient only if many circuits are printed. GPUs and FPGAs have more affordable costs, more or less $3,000 per board. All these features considered, we have to make a choice. ASICs are too much specific and too much expensive for our requirements, so we are not using ASICs. Concerning GPUs, their performance per watt ratio is too low in order to be convenient with respect to an FPGA, so we are not using even GPUs. FPGAs seem definitely to be the most suitable devices for our needs. They have a good performance per watt ratio, they are programmable, and their price is affordable. We are now working on the first case study through which we want to demonstrate the potential of the project. Our first implementation will be a matrix inversion, which is characterized by a really intensive computation, thus being a perfect case study for an FPGA-based system. If you have questions or if you want to know more about HAMS, you can contact us in many different ways. We will upload more material on our pages, so stay tuned. Thanks for watching.